All right, so what we're looking at here is we're looking at frequency diagrams. And this one in particular is going to be something I had a couple questions on. And it's a little tricky because of how things get kind of inputted here and some of the nuances and details that need to be done. So it's good for us to be able to kind of talk about this. Let me kind of help you out with it. That way you don't kind of like rack your brain. There's some big picture ideas that we want to get here, and so I'll kind of point them out. Okay? Actually, what I'm going to do is I'm going to copy down this particular table. Okay, I'm going to draw a table, so I want to insert the table. My table is going to have 1, 2, 3, 4, 5, 6, 7, 8. 2, 3, 4, 5, 6, 7, 8. Oh, excellent. And then it's going to be 8 by 4. So it's going to mimic the table that we have here. All right. So we're going to have, here's going to be our GPA. Okay. Here's our frequency. Here's our relative frequency. And here's our cumulative frequency. Now, this section is one of the first times in which we're going to really start to use definitions in order to help us understand statistics. And definitions are super important. We talked about that before in my in-person class. And now, for those of you who are doing this online, it should be really important to understand that definitions matter because what they do is they help you to guide your thinking, right? If I say, what is the frequency, you need to know what a frequency is. You don't need to know the definition. You need to know what it is, right? Okay. And if you're given a data set, how do you find the frequency for something? You also need to be able to create class widths, okay? Or you need to know what this class width thing is, or what is a bin. Those things, they're important to know, right? Because otherwise you're kind of just stuck. So you always want to, like, you're going to go through, you're going to do your reading, okay? You're going to have vocabulary. You want to keep those with you, right? You want to write them down inside of your notes. And then because you're going to use them as you're working on your homework, and then as you start studying for your exam. Okay, like we're gonna get used to kind of seeing these things, but what's really important is, do you know what it is to be what a frequency is? How is it related to relative frequency? How is it related to cumulative frequency? And so it requires you to kind of think about those things, those definitions in totality. Okay, so let's start out. We're gonna look at this problem. We've got a data set here, right? And it's a bunch of GPAs. Okay, so we've got a bunch of GPAs, and what we're gonna do is construct a frequency table. Okay. So it says, use the following data set above, fill in the following frequency table, write your classes in interval notation, and using LBUB. Now, what LBUB means is lower bound, upper bound. And what I want you to notice here is we've got some brackets. Okay, so brackets represent that we're going to make, this is going to be inclusive, right? Okay, it's going to be inclusive. And one of the key things we want to get whenever we're constructing classes, either for histograms or for frequency tables, is we need to make sure that no data element can end up in two in two classes. So no data element can end up in two classes. So what we're going to do for this one is my first GPA class is going to start, it says the bin will start with 1.0. So it's going to be at 1.0, okay? Now each class width, so we're going to kind of think about this, each class width is going to be 0.5. So probably the easiest way to think about this is that means that the next class width is going to start at 1.5. Okay? And the next class width will end up at 2.0, right? And so we're going to increase each class by whatever the size of the class width is. So the next one's going to be 2.5. The next one will be 3.0. The next one, with the closed bracket. And the closed bracket, 3.5. And then finally, we're going to need one that actually has 4.0 because we have a data element that says 4.0. Okay? All right. Now, we don't need the closed bracket here. That's not what we want yet. Okay? Now, what we're going to do is we want to put, what are all the different elements? What's the range of data elements that we're going to put in this GPA class? Okay? So, with that class width of 1.0, what I want to do is I want to add in the very last, okay, GPA that could be in this class. So the next one starts at 1.5, so this one's going to be at 1.4. Okay. Then we have 1.5, and since the next one's 2.0, it's going to go up to 1.9. Okay. And what you'll notice is this is actually a width of 5 if you're kind of thinking about it inclusively. Okay. Here's 2.0 to 2.4. 2.5 to 2.9, 3.0 to 3.4, 3.5 to 3.9, and then 4.0, and this one's going to go to 4.4 because it's going to be just like all the other classes, right? Where we go up right up to the edge, but we don't include it in the next class beginning. The next class, what we call it, it's a cutoff, right? Okay, the next cutoff of the class. So you can see we started at this thing that was the starting bin, 1.0, and then I just increased by 0.5 for each one of the bins, okay? Or each one of, we could also call these classes, right? By increasing by that class width. Then what I'm going to do for each one of these intervals, I'm just going to have all the values that could be in there because I'm using this closed bracket. So that closed bracket means I'm going to include it. If you remember from algebra, the open bracket means that I go all the way up to that edge, and that closed bracket means that I'm going to include the last value. Okay, open bracket means the last value is not included. Closed bracket means it's going to be included. So now what I have, if I look at my classes, is I can see that I've got classes here that are inclusive of all the data elements or possible ones that I could have, and no one data element can end up in two classes, which is exactly what I want. That way, you know, when I look at my data, I know exactly what it's telling me. Okay? So now I'm going to go into my frequency my data, and I'm just going to put in the frequency. Remember, frequency means how often does this data show up. So now I've got 1.1 here, so that frequency is 1, right? Let me repeat that. Frequency is how often does something in that class show up in the data. So there's 1 that's between 1.0 and 1.4, that's the 1.1. Now we go next, it's 1.8, right? Well, that's the only one that's going to be in 1.5 to 1.9, and there's a 1. For 2.0 to 2.4, I want to look for data elements 2.0, 2.1, 2.2, but we don't want 2.5, so there's now 3 of those data elements. 2.5 to 2.9, that's 2.5, 2.8, 2.9. There's 3 data elements right there, okay? Then 3.0 to 3.4, 3.0, 3.1, 3.2. So there's 3 data elements there, okay? And then we have 3.6, 3.6, 3.7, and 3.8. So there are 4 elements there, okay? And then finally, for 4.0 to 4.4, there's only 1 because we have that one 4.0. So now what I've done is I've actually summarized my data into this frequency table, okay? I've summarized it into the frequency table. So if somebody said, well, how many people in your data set had between a GPA between 2.0 and 2.4, the answer is there's 3 of them. Okay, and I can actually see that here. Do I know what their values are? No, I don't. Not from the frequency table. For the data I do, but not from the frequency table. But I do have them now grouped, which is cool. The next thing that I'm going to do here, just to check to make sure that my math is right, is I'm going to see, do my frequencies add up to 16? Because I have 1, 2, 3, 4, 5, 6, 7, 8 times 2 data elements. So there's 16 data elements. I want to see, did they add up to 16? So 1 plus 1 is 2, plus 3 is 5, plus 3 is 8, plus 3 is 11, plus 4 is 15, plus 1 is 16. So consequently, I do have 16 elements. This is all my data. So now next, I'm going to find my relative frequency. So again, relative frequency is the frequency divided by the total. So in this case, it's going to be 1, because there's 1 in that group, divided by 16, which equals 0.0625. Then the next one is going to be 1 divided by 16, and that's going to equal 0.0625 again. Next, notice for this class now it's 3, so it's going to be 3 out of 16, and that's going to be 0.1875. Okay, just be careful. I think this is going to ask you for four decimal places. Okay, so just make sure that you put in the right number of decimal places. So 3 out of 16 is the next one. 3 out of 16 is the next one. Okay, 4 out of 16 is the next one. There you go, it's 25%, right? And then 1 out of 16, and that equals 0.0625. Write these as decimals, okay? They're expecting decimals, you should put in decimals, all right? Now the next thing that I should do is I can actually go in here and just to check this, these all should add up to 1. Since the frequencies add up to 16, and we're just taking, these are fractions that add up to 16, 1/16 plus 1/16 is 2/16, plus 3/16 is 5/16, plus 3/16 is 8/16, plus 3/16 is 11/16, plus 4/16 is 15/16, and now we have 16/16. That's all of it. That's all you're going to get, okay? So that's your relative frequency, okay? Notice we take the frequency, we divide it by the total. There it is. Next up, cumulative frequency. Now what that is that's the number of data elements that are less than or equal to this class. So in this case, we start out, we're going to have 1 because there's only one data element that's less than or equal to 1.0 to 1.4. Then the next one, we're actually going to add up the frequency of this class plus the previous cumulative frequency. So it's going to be 2. Okay? Cumulative frequency for the next one, this one's going to be 2 plus 3, right? 2 plus 3, so that's going to be 5. Okay? Then we're going to have 5 plus 3, right? Okay? Because that's 5 plus these 3. Next up, we have the 8 plus 3. Okay? That's my 11, right? Then we're going to add 4. 11 plus 4, that's going to equal 15, right? So my cumulative frequency increases, and it's getting closer and closer to 1, which is what I should expect. Now, finally, for the last class, right, I'm just going to add 1 to 15, so that's 16. In any frequency table, if you have every single data element that you could possibly have, it's always going to add up to the total number inside the data set. Okay? And that's what it means to be cumulative. It means to add up everything that comes before it. That's what it means to be cumulative. So that's how we do these things with cumulative frequency tables. Okay? So with this one, we kind of you might have to watch this once or twice just to kind of understand these phrases: class width, what is a bin, okay? What are frequencies? How do we use data in order to find frequencies? Make sure that you understand relative frequencies, and then also cumulative frequencies. So there's a lot actually going on inside of this problem that you want to make sure that you understand and that you can go back and study. All right, that finishes the video.